Wow, it seems like a long time since I've made a video. So, welcome to Chapter 7 on data and data organization, and particularly to Lesson 7.1 on the mean, median, and mode. And you have seen all three of these words before, so this is going to be kind of a quick review lesson to go along with what's in your book, and we'll be working on these in class. Now, let's first translate mean, median, and mode. Okay, we usually write them in this order. The mean means the average. And the way I like to remember that is, imagine that I told you to find the mean of 30 numbers, all of which happen to be decimals. That would be kind of mean, and I told you couldn't use a calculator. Okay, so that would be mean of me. Okay, so that's how you remember the mean. It's it's probably the hardest one to calculate. Okay, the median basically means the middle number. That thing that's out in the middle of Georgian Way in front of the main entrance of the school, the grass thing they have to drive around, that's called a median. And it's called a median because it's in the middle of the road. Now, with median, basically all you have to do is, well, we'll get to how to solve it for each of these in a second. So the mean means the average, the median means the middle, and the mode, you look at the first two letters in the word. The first two letters are M-O, and so it means the one that also starts with M-O. That's the one that means the most. Okay, so mode and most both start with them, and that means the one that happens the most. So it doesn't mean it's the biggest number. It could be the smallest number. It's the one that happens the most times. So mean is the average, median is the middle, and mode is the most. All right, now let's get into how to actually find these things. Okay, the mean, otherwise known as the average, okay, all you do to average a bunch of things together is you add them up, which is called the sum, and you divide by how many there are. Okay, that's literally it. So you're going to do a careful addition. You're going to add up all your data points. If you have a number that happens more than once, you add it as many times as you have it, and then you divide by how many numbers there are. Usually we'll do mean to an accuracy of about the nearest tenth, which means when you do your division, you're going to have to divide two decimal places. Let's just make up some numbers real quickly here. Let's make this a little bit darker here. All right, so let's take the numbers 17, 24, 30, 22, and 16. And let's add those up and find the average. All right, now real quickly, ballpark this and take a look at the numbers. You go from 16 and 17 up to 22 and 24 and then 30. So without even really guessing, the average has to be somewhere in the middle. So I'm guessing it's probably going to be around 23, 24. So let's add this up and let's see what we get. So 7 and 4 is 11, and then 6 and 2 is 8. So that's 19, carry the 1. Now add up all the tens digits. That's 2, 4, 7, and 10. So we get 109. Okay. Now take that number, 109. Rewrite it over here and put another bar on top of it. This time make it a division bar. And you divide by how many numbers there were. There were 5 items, so we're going to divide by 5. All right. Put the decimal point in before we start because we know we're going to go out decimals if we need to. 5 goes into 1, it doesn't, but 5 goes into 10. I want you to be really careful when you show your division. So 5 goes into 10 twice. Okay. You always put it over the ones digit when you're dividing. Okay, 5 times 2 is 10. It's going to subtract perfectly, get 0, bring down the 9. 5 goes into 9 once, almost twice, but not quite. The remainder is going to be 4. I'm running out of room here, so I'm going to bring the 4 up here instead. And 5 goes into 48. So I get an average of 21.8, and that is the mean for this data. And is that where we said it would be? Yeah, it's kind of right in the middle of the numbers. Okay? All right. That's the mean. There's nothing really fancy or tricky about the mean, except that you have to be careful with your arithmetic. Now, we will talk about one thing that messes up the mean. It doesn't make it wrong, it just makes it not very helpful. And we'll talk about that in a minute, but we'll come back to that. So mean is the average. Add them up, divide by how many there are. Okay? That's literally all you do. Find the sum and divide by the number of things that you have. All right, next, the median. Okay, the median, you take all your numbers and you put them more. So let's take those original numbers we had back here. We had 16 and 17. I'm going to put them in order this time. 16 and 17, okay, followed by 22, 24, and then 30. 22, 24, 30. Okay, the first step in finding the median is to take your data and put it into order. A quick way to help you make sure that you got them all is count how many original numbers you had. We already know there were 5. Make sure that when you put them in order, you still have 5. It's real easy to leave one out or to forget one. All right, now for the median, what you usually do is you just cross out the first and last, then the second from the first and the second from the last, and whatever ends up in the middle is the median. So in this case, the median is 22. All right, now sometimes you'll run into a situation, we'll change the numbers. Let's say you have 3, 3, 4, oops, can't write today, 4, 5, 6, 7, 8. Okay? Now, when I find the median, again, they're already in order, so I cross out the first and last, I cross out the next 2, I cross out the next 2, and now I got this interesting situation where there's 2 things that tie for the middle. Well, this isn't really a big dilemma. All you do is add them together and divide in half. So add 4 and 5, you get 9. Half of that is 4.5. Or in a lot of cases, you can just look at it and just tell that 4.5 is going to be the number that's right between 4 and 5. Now that, again, is the median. So if you have a tie in the middle, just average those 2 middle numbers together. Not the whole thing, because that would be the mean. Just the middle 2 numbers. Okay? And again, be really careful with how many numbers you have and make sure you don't miss any. And you do have to remember to put them in order. Really, the only time people mess up with median, they either forget to put the numbers in order. That's a common mistake. Or when they're putting them in order, they accidentally leave one out. So if you're working on a quiz or a test, it's a good idea to actually, as you put the numbers in order, to cross them out in the original list. Not cross them out where you can't read them. Just put a line through them like we did with the blue lines right here. Okay. Also, count up how many things you started with, count how many things that you end up with to make sure you don't miss any or that you don't repeat any that you shouldn't. If you make a mistake, then you just do it over. Okay? So that's the median. Last but not least, probably the easiest one of all to understand at least, is the mode. All the mode is the one that happens the most. Okay? And so actually the one we just had is a good example. Look at the bottom one that I just made up. We had 3, 3, 4, 4, 5, 6, 7, 8. All right, so which number there happened the most? Well, we had 2 3s and we had 2 4s. Okay, so in this case, the mode would equal both 3 and 4 because they tied. Okay, that's really all there is to mode. So if you have one number that happens the most, that's the mode, period. Now, there are a couple special rules about mode. If none of the numbers happen more than once, like let's say 1, 2, 3, 4, 5, each number happens once. Okay, so you could think of this as, well, actually, they kind of all tie for which one happens the most. Well, most means that one of them happens more than something else. So if they all tie for the most, then we say there's no mode. Okay, even if all those numbers had happened more than once. So let's say we had 1, 1, 3, 3, 5, 5. Okay, now we have all the numbers, well, at least the ones that happen, 1, 3, and 5, and they all happen more than once. There's still no mode here because we have a 3-way tie. Okay. However, let's say I add one more number to this list. Okay, now 1s happen twice, the 3s happen twice, the 5s happen twice, and the 6 only happens one time. So in this case, we have a 3-way tie, and you'd say that the modes now, with the 6, are 1, 3, and 5. So basically, to be a mode, you have to happen more than something else that actually happened. Okay, we're not counting the numbers that aren't there, but in this case, 6 happened once, and 1, 3, and 5 all happened more. So you can almost think of another MO word. In order to have a mode, one thing has to happen more than something else. Okay. Now you could literally make up a data set with 100 numbers in it, and if you had 2 1s, 2 2s, 2 3s, all the way up to 2 50s, you would literally have a 50-way tie for the mode. Okay. Actually, no, you wouldn't. Because in that case, they would all tie, so there'd be no mode. But if you threw in one extra number, like 151, like we did with the 6, then you would literally have all the 50 numbers would tie because they all happened twice, and the poor little 51 only happened one time. Okay, so that's the mode. Now, I said we were going to talk about one more thing, and that's a word that might be a little bit new to you. It's called an outlier. And if you just think about what that word means in English, an outlier is something that's kind of way far away from the rest of the group. Well, it's the same thing with numbers. So if you have a group of numbers like this, let's say you have 2, 2.5, 2.7, 3, 17, 3.1, 2.8. Okay? Well, clearly, all of these numbers are all kind of in the ballpark of 2 or 3, with the exception of 17. All right? And what happens when you have an outlier like this, especially one that's way far away, like so big as 17? Then what's going to happen is I average all these numbers up. I'm going to get an average that's going to be like 3.5, 4. Okay? Well, if you look at the numbers, actually, it might even be higher than that. It probably would be about 4. Well, look at all of the numbers except for 17. 4 is way bigger than all of them. Okay? But yet, except for 17. But it's not really that close. It's not the typical number. In fact, while I'm talking here, I'm going to go ahead and add these up on my calculator. Now, we're going to do means by hand. Okay, but real quickly while I'm talking, I just want to see how high the mean is. So I'm going to add up all these numbers, and I get a total sum of 31.1. Now count how many there are. Again, we're going back to the mean here. Divide by 7, and my average comes out to be 4.44. So right now the mean is 4.4. Okay, we'll round to the nearest tenth. So the extra 4 says to leave it alone. All right, now if I put them in order, again, let me show you how this works. So I'm going to put a 2 first. Let's see, what's the next smallest number? It looks like 2.5. Okay, I started out the first little bit, I was in order. Followed by 2.7. Notice that I'm crossing these out as I go. Then 2.8 is next from the end. Okay, so cross that out. Followed by 3, 3.1, and 17. We'll cross 3, 3.1, and 17. Now count how many numbers I start with. 1, 2, 1, 2, 3, 4, 5, 6, 7. Make sure my new list has 1, 2, 3, 4, 5, 6, 7. Now if I find the median of this one, the median, I'm going to cross out the first and last, the next 2, the next 2, and I get a median of 2.8. Now, we're going to talk a little bit about this. Which is a better measure of central tendency? In other words, which one, mean or the median, is a better reflection of a typical data point? Well, we argued that 4.4, even the biggest number, 3.1, it's like 1.3 bigger. And for everything else, it's even more than that. Sometimes for some numbers, it's more than double. Like 2 is less than half of 4.4. Well, 2.8, on the other hand, 2.8 describes really well all of these data points right here. The only one it doesn't really include is 17. Okay, so you could very much make a very good argument that the median is a much better representation of the data than the mean because the outlier skewed the data. Okay, and so that's what happens. If you have an outlier, it messes up the mean. So anytime you're ever asked what is the best measure of central tendency, the question is really asking, does the data set have an outlier? Either a really small number that's way far away from everything or a really big number that's way far away from everything. And if it does, then always go with the median as the better measure of a typical central value. Okay? Otherwise, the mean or the median works pretty well. Okay, the mode, because of its weird rules, sometimes it gives you a decent typical data point. More often than not, it doesn't. Okay, so we're going to talk more about these, and we're going to talk about some of the some of the things to really watch for. But one more time, let me remind you: with mean, just be really careful with your math. With median, remember to put things in order. And remember to break the ties if you have two things in the middle. And for mode, you got to remember those kind of complicated rules for first of all whether or not there is a mode, and second of all how to find it. And don't forget you can have multiple ties for the mode. All right, so that's it. Thanks for watching, and we will do some practice problems in class tomorrow. Hope to see you then. Thanks all for watching. Goodbye.